Welcome to Lesson 7 of Unit 5a, where we're solving inequalities with negative coefficients. There's the big difference. Now, just to warm up our brains, whether you're doing this with a group or partner or alone, I want you to look at this inequality. Negative x is greater than or equal to negative 4. And I want you to make some predictions. What do you think the solutions on this number line might look like? Where would your boundary point be? Is it going to be an open dot or a closed dot? Would the solutions move to the left or to the right? And what is one possible solution? Just play around with this, explore it on your own, and then come on back here and I will show you some of the things I think about when I'm making sense of these kinds of inequalities. My hope is what most of you did was you used your algebra skill of either multiplying both of these sides by -1 or dividing by -1. So you would come up with, well, x can be greater than or equal to 4. And then my hope is that you went ahead and you tested some of those. So that would mean that a possible solution is 5, right? X should be able to be 5. Right? Let me go ahead and just graph this real quick. That would mean that we have a closed dot at 4, and all of our numbers greater than 4 should work. But what if we do a check for 5? When we plug in that check, we get this inequality, -5 is greater than or equal to -4. And that is not true. -5 is all the way over here, and -4 is right here, so -5 is actually less than -4. So something weird happened here. And indeed, something weird happens when we multiply or divide by a negative number. Let's explore this with just using some of our algebra concepts. What you have here are two equations, well, one equation, I'm sorry, you have the equation where 6 is equal to 6, that is true. And you have the inequality where we know 1 is greater than 0. That is true. Let's do some algebra moves and just explore this a little bit. Let's add 3 to each side. We should be able to do this as long as we're doing the same thing to both sides of our equation or inequality. We should come up with true statements. In this case, 9 does equal 9, so that's still true. And in this case, 4 is greater than 3, so that's still true. Let's try dividing each side by 2. Okay, well here we end up with 3 equals 3. That's still true. Here we end up with 1/2 is greater than 0. That's still true. All right, now let's try dividing both sides by -1. Okay, what we come up here is -6 is equal to -6, still true. And here we come up with -1 is greater than 0, which is not true. -1 is actually less than 0. This is going to be a pattern you see every single time you try to multiply or divide an inequality by a negative number. One more exploration. Okay, let's take a look at an inequality where we just pop our x on the other side of that inequality sign. We have the inequality where -6 is greater than -x. So let's start here by just picking a number that is less than -6. You can pick any number you want. I'm going to pick -10. Because I know for sure that -10 is indeed less than -6. Okay, now let's divide both sides by -1. Sure, that's an algebra move. If you do the same thing to both sides of an equation or inequality, it should come up with a true statement. Is the inequality statement still true? Is 10 less than 6? It's not. What the heck is going on? What do we do? Well, the answer is when you multiply or divide both sides of an inequality by a negative number, you must flip the sign. You gotta flip it. 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 You got to, gosh darn, flip that sign. Because what is happening when you multiply or divide by a negative, it is telling you that multiplying or dividing by a negative will create the opposite of a solution set, meaning that when we do that multiplication or division, what's happening is we are getting the answer of all values that are not in our solution. So if we flip that sign, then we get all the values that are in our solution. You gotta flip the sign if you multiply or divide by a negative number. Get up right now and say that to somebody in the classroom. Maybe it's me. Maybe you're at home and it's to your dog, whatever. Get up and tell someone, hey, if you multiply or divide by a negative number, you gotta flip your inequality sign. All right, let's try one. So my first step, I'm gonna get rid of my constant. So subtract 10 from each side. Rewrite it. Negative 3x is less than 12. Now I'm gonna divide both sides by negative 3. And sometimes when I do this, I just go ahead and I flip my sign right then and there. I say, well, okay, I just did a negative, so I know that I now need to flip my sign around. And what I'm gonna come up with is x is greater than negative 4. And let's do a quick check. I'm gonna pick a number that is at least 1 point off of my boundary point. So if my boundary point is negative 4, I'm gonna pick x is negative 3. It's 1 larger. Go ahead and replace my variable with that. Okay, and I come up with 9 plus 10 is less than 22, and it is true that 19 is less than 22. What if we had forgotten to flip our sign? What if in this step I had left it as less than? And then we'd done this check. And say we then checked for negative 5. Let's try that instead. So checking for when x is negative 5. Pop that back in our original inequality. Said that 15 plus 10 is less than 22. 25 is less than 22. And that would have been a sign to us that we did something wrong, because that is not true. More often than not, what you did wrong is you forgot to flip your sign. So you might just make a note to yourself at that step when you go in, just like I did, to divide by a negative, to flip that dang sign around. All right, now let's graph this thing. Make sure when you're graphing that you are graphing your solution set. I have seen some people try to come up to their original inequality and graph for 22, but you want to graph your solutions. So right here, we're going to have an open dot at negative 4, and we are saying that this can be all numbers greater. So here's negative 3, here's negative 5, and it can be any and all of those. All right, try it with this one and throw in some fractions and decimals your way, and come on back and see how you did. Okay, I ended up with x has to be less than or equal to negative 21. I'm gonna do my check with, let's just do negative 22. When x equals negative 22. So when I tested it with negative 22, I ended up with the inequality that 7.5 is greater than or equal to 7, and that is true, so I'm happy. Go ahead and graph it. It's going to be a closed point because negative 21 is a part of that solution. So closed point at negative 21, and it's going to be all numbers that are less. So here's negative 22, here's negative 20, and I am happy. All right, go ahead and grab your journal problems. Do your best. Call me over if you get confused. Always happy to help. You guys rule. Thank you.